in your mind. But you're not going to do this for every possible move, of course, because there are too many of them, right? You're only going to be doing it for a couple of different options, right? Like here, you're going to look at the knight, the queen, and the way you narrow down these options is via intuition, is via pattern recognition on the board. So, and you build that up very much through experience, right? You've mined your past experience and consciously to extract these patterns, and that's very much type 1. So you're using type 1 intuition to make type 2 calculation tractable. So how is the merger between type 1 and type 2 going to work? Well, the key system 2 technique is discrete search over a space of program. And the blocker that you run into is combinatorial explosion. And meanwhile, the key system 1 technique is curve fitting and interpolation on the curve. So you take a lot of data, you embed it on some kind of interpolative manifold that enables fast but approximate judgment calls about the target space. And the big idea is going to be to leverage these fast but approximate judgment calls to fight combinatorial explosion and make program search tractable. A simple analogy to understand this would be drawing a map. So you take a space of discrete objects with discrete relationships that would normally require combinatorial search, like pathfinding on a subway system, for instance. And you embed these objects into a latent space where you can use a continuous distance function to make fast but approximate guesses about discrete relationships. And this enables you to keep combinatorial explosion in check while doing search. And this is what the full picture looks like. This is the system that we are currently working on. AI is going to move towards systems that are more like programmers that approach a new task by writing software for it. And when faced with a new task, your programmer-like meta-learner will synthesize on the fly a program or model that is adapted to the task. And this program will blend deep learning submodules for type 1 subproblems, like perception, for instance, and algorithmic modules for type 2 subproblems. And these models are going to be assembled by a discrete program search system that is guided by deep learning-based intuition about the structure of program space. And this search process isn't done from scratch. It's going to leverage a global library of reusable building blocks, of abstractions. And that library is constantly evolving as it's learning from incoming tasks. So when a new problem appears, the system is going to search through this library for relevant building blocks. And whenever in the course of solving a new problem, you're synthesizing a new building block, you're going to be uploading it back to the library, much like as a software engineer, if you develop a useful library for your own work, you're going to put it on GitHub so that other people can reuse it. And the ultimate goal here is to have an AI that can face a completely new situation and is going to use its rich abstraction library to quickly assemble a working model, much like a human software engineer can quickly create a piece of software to solve a new problem by leveraging existing tools, existing libraries. And this AI is going to keep improving itself over time, both by expanding its library of abstractions and also by refining its intuition about the structure of program space. This system is what you are building.